Okay. Whoa, is that in focus? Yeah. Okay. So I'm on the back of that first page. We're going to look at bond types. Now, when it's nonpolar covalent, is talking about, when it says 0 to 5, it's talking about the percentages. So just put percent up here so you'll know that's what it's referring to down here in this scale. So nonpolar covalent, 0 to 5% ionic character. This is a covalent bond in which the bonding electrons are shared equally by the bonded atoms with a resulting balanced distribution of electrical charge. Okay? Now then, from 5% to 50% is classified as polar covalent. This is a covalent bond in which the united atoms have unequal attraction for the shared electrons. And we will be looking at this a lot next week about polar versus nonpolar. Ionic, okay, 50 to 100% ionic character. This is a chemical bond in which the electrons are so unequally shared that the electrons are transferred between the united atoms. A metal atom will give one or more valence electrons to a nonmetal atom. Okay? Now then, what you see down here is basically the electronegativity table out of chapter 5. Okay? I want to write down here at the bottom, I want to write the definition of electronegativity again for you. Electronegativity. A measure of the ability of an atom in a chemical bond mark out bond and write compound. To attract electrons from another atom in the compound. A measure of the ability of an atom in a chemical compound to attract electrons from another atom in the compound. Okay. In chapter 5, we learned that fluorine is the most electronegative element on the periodic table. Down here, francium was the least. Okay. On this table, you see that it has all of your electronegativity values posted here on this table. This is why I kept it separate and didn't staple it, kids. We are going to use this table to function on your assignment. Now then, what I would like for you to do is first, let's fill in right here. Let's put, I'm on the, see how I'm kind of lapped over? Write ionic right here. Write polar here. And then you'll kind of have to turn it sideways and write nonpolar here. Did I go off the video? Yep. Okay? Alright. Now then, you see here they only have covalent? Alright, please write polar. Nonpolar. Yeah, nonpolar. Okay? Fill in your difference in electronegativity character. That's what these values are underneath the little scale, is the difference in electronegativity. So this one is 3.3, 1.7, 0.3, and 0.0. So between 1.7 and 3.3, when you subtract the two electronegativities, if it falls between this sliding scale, it's classified as ionic. When you do your math and it falls between 1.7 and 0.3, it's classified as polar covalent. And when you do your math, if it falls between 0.3 and 0, it's classified as nonpolar covalent. Okay? Alright, so an example. Need this where I can. Okay. So looking at your table, we're looking at sodium and fluorine. You will always just take the larger number and put it first. We don't want any negative values. Does everybody understand? So fluorine is 3.98. So off to the side right here, put 3.98 minus. Go look at sodium, and it's 0.93. And yes, I want you to show your work. Equals. And that comes out to be, when you do the subtraction, 3.05. Okay? Now then, where does 3.05 fall up here in your sliding scale? Ionic. So put an I. Okay? Alright, let's do one more. Go find oxygen. The value is what? 3.44 minus. Go find magnesium, and its value 1.31 equals, and when you do the math, it comes out to 2.13. Where does 2.13 fit? Ionic. Okay? That's what you're going to do. Anybody have questions? Okay. I expect you to finish it in class so you do not have any homework.